Okay, so for this next one, we're asked to prove that triangle SVT is congruent to triangle UTV. STV is this bottom left triangle, UTV is the top one. So we're going to just write down what we're given. What we're given is right in the picture. We're given tick marks on TU and SV, so we can say TU is congruent to SV. We also have the little arrows, so that would mean that those lines are parallel as well. So we can say TU is parallel to SV. We're given both of those things. Now, we have one pair of congruent things. We need three to use one of our big four. So we look for our visual freebies first. We have a shared side. So we can say TV is congruent to itself. Always look for vertical angles or those shared sides. That is our reflexive property. I mentioned in class the other day we're going to use reflexive property a lot, and I wasn't kidding. And then finally, we have to use these parallel lines somehow. So this goes back to chapter 3, but what we have is two parallel lines being cut by a transversal TV. So you have something that kind of looks like this, and then you got triangles over here. So the angles we have are actually that angle and that angle, which we know those are alternate interior angles, so those can be congruent. So we can mark in that this angle is congruent to that angle. They're both between the parallel lines and on different sides of the transversal. So we can name this angle down here. We wouldn't name it angle V, because V would be this entire big thing. We would name it angle SVT. And then this angle here, we can name it VTU or UTV. Doesn't really matter. We'll call it UTV. Notice these are just angles. I'm not saying the whole triangle. I'm just talking about this little angle here. Those are alternate interior angles. And now we can look at our picture and we can recognize, oh, we do have enough to say the triangles are congruent because we have two sides in each triangle and the angle between them. So we can say the triangles are congruent because of SAS. So triangle SVT is congruent to triangle UTV because of side, angle, side. So once again, notation is important. Like if you look at just line 3 and line 4, to the untrained eye, they look like they're saying the same thing. But the angle symbol means we're just talking about this angle specifically. The triangle means we're talking about the entire triangle. So just be careful of that. Okay, we're going to do one more proof, and then we'll kind of wrap up with like a general overview of how to do any of these. So the last proof I want to do in this video is given this picture, and given that AC is congruent to BC, and that D is the midpoint of AB, prove the triangle on the left is congruent to the triangle on the right. So we'll put the given down. AC is congruent to BC. D is the midpoint of AB. I'm okay with you abbreviating midpoint as MP. That is given. Okay, before we talk about midpoint, let's look for our visual freebies. Do we have vertical angles or a shared side? Yes, we have a shared side again. So CD is congruent to itself. So we would use the reflexive property again. And now D being the midpoint of AB, we need to use that somehow. D is the middle point of AB. So if we ignored the entire top, oh my gosh, that is so bad. Still not ideal, but I think we get it. This is A, this is B, and this is D, just focusing on that. If D is the midpoint, what that does is that means that AD and DB have to be the same. So for our picture, I'll do a little triple tick mark, and we can say that AD is congruent to DB. We've never used this reason, but we just know that's what a midpoint does. Kind of like definition of bisect, it just cuts it in half. So we can just put definition of midpoint, or definition of midpoint, or def of MP if you want to be really lazy about it. And then looking at the picture, we do have enough to say the triangles are congruent. We can do this because we have all three sides congruent, so we can say that ACD, triangle ACD, is congruent to triangle BCD. And that is because of SSS, or side-side-side congruence. We showed all three sides were congruent, so that means the triangles have to be the same size and the same shape. Okay, so what I have on this page, it looks like a lot, but this is basically the process for doing any of these proofs in Chapter 4. So the first thing you do is you write down the given. Sometimes that's from words, sometimes it's just from the picture you're given. Then the first thing I like to do, because most of the time you have it, sometimes you don't, but most of the time you either have vertical angles or you have a shared side, the reflexive property. Always do that first and just get it out of the way. After that, you get to use kind of your weird stuff. So like a definition of midpoint, you can say that two segments are congruent. If ever you have a bisector, that means that thing is cut in half. Typically, this is the one that's the most confusing because we don't always read or are careful about what's being cut in half. So just double check you're cutting in half the right thing, whether that's a segment or an angle. And then finally, if you have parallel lines, you can use alternate interior angles, corresponding angles, alternate exterior angles, etc. to your advantage. And then once you're there, you should get enough information to use one of our big four. So side, 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 angle, side, angle, or angle, angle, side. So it's really the same process for all of these. So if you were to rewatch this video, you'll notice I do this exact process for all of these. So go ahead and give these a shot. Try them out and just see how they go. It's our first day doing these, but I hope that you'll find that you like these proofs better than maybe the stuff that we did in earlier chapters.